Hello and welcome. My name is Sarah Corpy, and I will be the host and moderator for this ADEIL conference session. Thank you for joining us for How to Use Machine Learning to Increase Student Retention in an Online Environment. Please welcome Dr. Yamil Guevara.
Thank you. I really appreciate it, Sarah. Welcome, everyone. It is an honor to be here. I've been an online associate professor at Ashford University for over 8 years. So I've been here a long time, and I really enjoy Ashford University. So let's begin. The title of my presentation is How to Use Machine Learning to Increase Student Retention in an Online Environment. The learning objective of this presentation are as follows. But at the end of this presentation, you will be able to explain what is the distance educational deficit, discuss the forthcoming challenges of online students, discuss big data in higher education, understand the differences between supervised machine learning and unsupervised machine learning, create a machine learning model using R programming, develop an at-risk student learning profile using machine learning, and explain what is dirty data and how to clean dirty data. So let's begin our presentation. So it is no surprising, it is no secret that online university, they experience a higher withdrawal rate than traditional university. And their graduation rate is actually lower than traditional universities. And this is not because online universities don't have a retention plan. This is quite the opposite. They actually do have an online retention plan, and they do their very best to help the student be successful. They really care for the students. For every university that I work for in an online environment, they really care. They prepare the students to be successful. Many of them, what they do before students can first log into the first class, they make sure students know how to log into the classroom. They know how to post their assignments. They know how to respond to other students, and they know what is expected of them in an online environment. So online university, they do their very best to prepare students before they start their program. Not only do they prepare students, but they actually have a whole staff behind them that helps students be successful. For instance, many universities, they have a dedicated academic advisor for the student that actually followed the student throughout their program, helping the student with any issue the student faces. And they have an admission advisor that helps the student during the first year of classes. And on top of having a dedicated staff to help the student be successful, a lot of online universities, they have professors that are well-trained to help students be successful. And for instance, I do my very best to help my students be successful. And if I see if my student is struggling academically, and I think that student needs additional help, I will contact the academic department so they can help them and provide the resources they need for the student to be successful. So online university, they do their very best for online students to be successful. And despite all their efforts and their strategy to retain students, they still experience a lower graduation rate than traditional university. There's been some scholars who argue that we're doing our students a disservice, that we need to do more to help our students, online students, be successful. And I agree with them. I think we can do more. I know we've done a lot, but we can do more. We can go above and beyond. And this is what this presentation is all about. I'm going to show you how to create a student profile of those students who are at risk of failing the program. And you can use this student profile to be proactive by providing the resources and the support that students need before they fail. So I'm gonna show you how to do this using R programming. R programming is very easy to use. It's not that complicated. You'll see it as we go along. I'm gonna show you how to use R programming. You're gonna be surprised how easy it is and how you can use it to retain your students. So let's begin. So let's continue. So what are the challenges that makes online learning so challenging for students? Well, there are 4 challenges. The first one is digital literacy. A lot of times, our students have been out of school, out of college for over 20 years. I get a lot of those students. Some of my students have been out of college for 20 years, and they come back to school to complete their master program or their bachelor's program. They want to complete it and get it over with. But in addition to being out of school for over 20 years, then they had never used computers in the internet to go to school. So this is something brand new. So it makes it more complicated. So learning how to learn in an online environment makes it more complicated because on top of that, you haven't been out of school for 20 years. So it's very complicated at the beginning for many online students. And it's very important for us online universities to make sure that when we create courses, online courses, that these online courses are structured in a very intuitive manner. Because if they're not structured in a very intuitive manner, then it's going to be very difficult for the students to understand what to do in an online environment. And I can speak from experience. Last year, I decided to take 2 online classes at the University of Illinois. So during my first online class at the University of Illinois, I'll be honest with you, I was completely lost. I didn't know what to do. I didn't know where to find the course syllabus. I didn't know how to post, how to submit the assignments. I was feel like, something, I cannot deal with this. I'm just gonna quit the course. I'm not gonna take the course anymore. But I decided to stick around and continue with the course. And I asked a lot of questions from the TAs. Now think about this. I have over 14 years of online teaching experience and administrative experience. And I was struggling with completing my first online course at the University of Illinois. Imagine if I were a student that is not familiar with online education and that have been out of school for over 20 years, I probably would have failed that course because it was not intuitively structured. It was very difficult to understand. So it's very, very important for online university to make sure that when we create a course, it's structured in a very intuitive manner to help the student be successful. Technical issue. A lot of our students, they have old computers, very slow computers that cannot run sophisticated software. And that can be an issue. That can cause a lot of problems for the student. Or they may have very low, slow internet connection. And that can cause problems as well when it comes to technical issues. It's very important for online universities to make sure that they provide the students with the technical support that they need 24/7, because the students will run into technical issues. It's not if, it's when they will run into it. Time management. A lot of my students are working adults. They have a full-time job, and many of them, in addition to having a full-time job, they have all these part-time jobs, additional jobs that they have. So they have a full-time job, they have additional work they have to do, other jobs. And on top of that, many of them are single mom, single dads, they have families to raise. So it's very difficult to manage your time. And now you add going to school to that schedule, to that hectic schedule. So students they experience, they have to juggle all these responsibilities. They have to go to work, they have to raise a family, and they have to go to school. So time management can be very difficult. So it's very important for online universities to provide like a workshop, time management workshop for the students. So that way the students learn how to manage their time and be successful in an online environment. So that's very important. Motivation. In an online environment, you don't get to see your classmates and your professor face to face. And that can create a disconnect. And this disconnect may lead to procrastination. Because if you don't see your classmates, if you don't see your professor face to face, you may feel like, you may not be motivated to complete the assignments. You may not be motivated to engage other students in discussions. You may feel like, this may not feel like real. It may feel like it's not real. It's a computer. So it's very important that for online universities, that the assignments be dynamic, that the assignments be engage the student and the faculty and the students with the other students in a very dynamic environment. That way it feels real. That way it motivates students to continue with the program and not procrastinate. So these are the challenges that make online education very challenging, more difficult than traditional universities. Now, are there variables that can be used as predictors of academic success in an online environment? And if there are these variables, then we can use this variable to build a profile of a student that is at risk of failing the program before they even begin the program. Fortunately, yes, there are those variables. Dr. Pamela Dupin Bryant in 2004, she used multi-regression analysis to identify 5 variables that were predictor of academic success in an online environment. She found that GPA, class rank, number of previous courses completed in an online environment, training in internet searching, and how to use a computer were variables that were predictors of academic success in an online environment. So, and she used multi-regression analysis to find these variables. So definitely, so there are variables that we can use to build a profile and use this profile to prevent academic failure. So we're going to be using machine learning to create this profile. And online universities, they are collecting massive amount of data on online students. They know when students log in. They know how often students log in. They know how much they participate in an online environment. They know how long they stay in online class. They know how much they read or don't read. They have all this massive information on online students. They're collecting massive amount of information. And this is what we call big data. Big data is like massive number of variables that we're collecting on students. And unfortunately, we cannot use multiple regression analysis to analyze this data because multiple regression analysis is only limited to 5 independent variables. If you use more than 5 independent variables in a multi-regression analysis, you're going to run into problems with multicollinearity, and you don't want that. So in order to analyze big data, which has hundreds of variables, you need to use something more than multi-regression analysis. You need to use machine learning. Machine learning can analyze hundreds of variables very easily without any problems and millions of observations. So that's what we're gonna be using in this presentation. We're gonna be using machine learning to analyze big data, data that has hundreds of variables. And of course, just like I mentioned, you cannot use multiple regression analysis with big data because multiple regression analysis is only limited to 5 independent variables. So let's continue. So we're gonna be using supervised machine learning and for our demonstration. There are 2 types of machine learning. There's supervised machine learning and there is unsupervised machine learning. In supervised machine learning, you tell the computer what are the independent variables and what is the dependent variables. In unsupervised machine learning, you don't tell the computer what are the independent variables and what is the dependent variables. You let the machine learn and find that pattern in the data for itself. So you just let that machine learn by itself. You don't tell her anything. You don't guide it. The most common machine learning algorithm is classification regression trees, or CART. And the reason it's the most common is because you can use categorical or continuous variables to make predictions on binary or nominal variables. And we're gonna be using CART to build a machine learning profile that can be used to create a profile of those students who are gonna be at risk of failing the program. So let's do that. So I'm gonna use R. Can everybody still see my computer screen? I believe you can. So I'm gonna use R. R is actually the most sophisticated data analysis software out there. It's not only the most sophisticated, but it's actually free. You don't have to pay anything for it. You just can download it. It's completely free. I don't recommend for you to purchase SaaS or SPSS. And the reason I don't recommend that is because those software, even though they're powerful and amazing, they're very expensive. You can pay a lot of money. So you're going to be making university pay a ton of money for software that you don't need to pay. You don't need to make them pay for that. You can use R, and R will do your data analysis. It will do your machine learning modeling for free. So I will definitely use R for all my data analysis and machine learning modeling. So the first thing we need to do with R is to load our libraries. The libraries that we are going to be using to build a learning machine model. So when I'm going to use R part is the card algorithm that I just discussed in my previous slide. And I'm going to be using R part plot. The R part plot is, I'm going to use that to plot or visualize my machine learning model. So I've just uploaded my machine learning libraries, and now I'm going to upload my data. I'm going to call it admission. Okay. Okay, so I uploaded my data. But before I begin and before I continue, I would like to make a comment that this data is not real data. This data is fake data, or it's mock data. It's not real student data. And the reason I don't use real student data is because I don't want to, because student data is actually protected by FERPA. So I cannot use the real student data here in this presentation. But for demonstration purposes, this fake data will do fine. So now before we
Emil,
actually, yeah.
can I interrupt you
Yeah.
for a brief second? I am still seeing your PowerPoint
Oh,
program. I'm not
oh,
sure if you intended us to
sorry.
see something else. I'm sorry for the interruption.
No, thank you.
If
Can
you
you
stop,
see?
yeah, there we go.
Okay, you see
Yes,
it?
Mhm.
Okay, I would like
yes,
to
thank you.
apologize. It seems like you were seeing my presentation. Okay, so now you can see the R, right?
Yeah, can you start again? Because this is the first time seeing this data, please. Can
Oh
you
yeah,
just
no
go back a
problem.
little bit? Thank you.
No problem. So the first thing I did during this R programming is to upload my libraries. And the library that I'm using is RPart. RPart is the card algorithm that I mentioned in my previous slide. And the second library that I'm going to be using is RPart plot. And RPart plot is what I'm going to be using to visualize my machine learning model. And of course, I already uploaded my admission data. It's already uploaded, so if I can re-upload it again, but here's the code to load your
So
data.
that data is fake, right? The admission data
Yes,
you
this
sent? Okay.
data,
Okay.
exactly. This admission data is fake. It's not real data. You cannot use real data in public. Okay, so I already loaded my libraries. I already my data. So it's time to build my machine learning model. I'm going to call my machine learning model ML for machine learning. And I'm going to use RPart to create my machine learning model. That's the algorithm that I'm going to be using. My dependent variable is completion. Oh wait, sorry, I apologize. Before I do, I need to look at my data. So I'm going to look at my data. It's always a good idea to always look at your data before you do any analysis on it. Okay. So here's my data. I have 400 observations. Okay. And I have 8 variables. Remember, since we have more than 5 variables here, we cannot use multiple regression analysis because if we do, we're going to have problems with multicollinearity. But machine learning doesn't have that kind of problem. Machine learning can analyze hundreds of variables without any problems and make sense out of them. So here we're going to use our machine learning instead of multi-regression analysis. Our variables are TOEFL score, university rating, statement of purpose rating, letter of recommendation rating, research, chance of admit rating, GRE score, and completion. Completion is coded as success and failure. So we're gonna use our first 7 variables as independent variables, as predictive variables of completion in our model, in our machine learning model. So let's do it. Let's create a machine learning model. We're going to call a machine learning model ML for machine learning. Our part, our dependent variable is going to be completion. Our independent variable are going to be all the other variables that are remaining. Our data is going to be admission. Our method is going to be classification. And our model is going to be true. So we just built our machine learning model, and it took like a nanosecond. It was very fast, very quick, because it's not that many. The data set is only 400 observations in 8 variables, so the computer can do that quickly without any problems. However, if it was there were more variables and more observations, then it might take a little bit longer. So let's look at our model. So I'm going to use our part plot to look at our model. And our model is ML. Our type is 3. Our digit is 3. And here's our model. So let's look at this model. So the machine created a model. And how can we use this model to build the profile of those students who are going to be at risk of failing? And how can we use this profile to prevent online failure of our students? How can we do this? So here our machine learning identified 3 kinds of students. The students that fail the program, the students that are borderline, and the students who are successful. So what are the characteristics of those students that fail the program? Well, the characteristics of those students that failed the program are those students that had a TOEFL score of less than 102, and those students that had a chance of a mid-score of less than 0.605. This means that if you had an incoming new student class, and there was a student in that class that had a chance of a mid-score of less than 0.605, and a TOEFL score less than 102, then you knew that student is at risk of failing the program before they even step into the into the first online class. Before they step into the class, before they even begin the program, you know that student meets the profile of a student that's going to fail the program. And since you know this student is at risk of failing the program before they even step into the online class, even before they first log into the first online class, you know this student is going to fail the program. So I'm going to be proactive. Instead of waiting for this student to fail the program, I'm going to be proactive by preventing the failure. I'm going to provide this student with the support and the resources that he or she needs to be successful in my online program. Because I already know this student, there's a high likelihood that this student will fail. So I'm going to use this machine learning model to build a profile. And my profile is that any student that has a chance of a mid-score less than 0.605 and a TOEFL score less than 102, I know that student meets the profile of those who are most likely going to fail the program. And I'm going to use that profile to prevent failure by providing those students with the resources they need to be successful, thereby preventing failure instead of reacting to failure. And that's how you can use machine learning to create student learning profiles of those students who are at risk of failing the program and using those profiles to prevent failure. And as you can see, machine learning is very easy. I'm gonna go back to my presentation. Gonna go back to my, can everybody see my presentation? I hope everybody can see my presentation now.
Yes, we're seeing your PowerPoint.
Excellent. So I'm going back to my presentation. We just built the machine learning model. It wasn't that easy. I mean, it was that easy, right? It was very easy. It was not complicated. So if machine learning is so easy to do, why is it that sometimes some people are afraid of it? The reason sometimes people are afraid of it is because building a machine learning model is not complicated. It's very easy. What's difficult is cleaning dirty data. So what is dirty data? What is that? Dirty data is when the data is not properly formatted or there's inconsistent formatting of the data when it's entered. And it creates a lot of issues. Look at the column on my left, or your left. This column we have on row number 2, row number 3, row number 4. We had the same student. The student's name is Julio Lopez. He's the same student, but in row number 3, his name has been entered in lowercase. In row number 4, his name has been entered in uppercase. The computer is not intelligent. The computer only follows instructions. So when a computer sees this, it assumes that Julio Lopez in row number 2, 3, and 4 are 3 different students, because it assumes that they're, because of the lack of consistency in the formatting, it assumes that those are 3 different students. So before you can run analysis on this data, before you can do machine learning on this data, you need to clean up that data. That means making the formatting consistent. So you will need to merge row number 2, 3, and 4 into one row. And the column on my right, the data has been cleaned up. Now we only have one Julio Lopez. So row 2, 3, and 4 has been merged into one row and become row number 2. Now the data on the left side, on my right side, has been cleaned up. And that's what takes the longest. Cleaning up data can be tedious, it can be time consuming. But once you clean up the data, you can run the analysis and the machine learning will do it quickly, very fast. Well, it all depends on what kind of computer you're using. The best machine, the best laptop, the best computer designed or most appropriate for machine learning is our gaming laptop or gaming desktop. Why is that? Because these gaming computers, they have graphics, very powerful video graphics cards. And these video graphic cards can run millions of calculations simultaneously, immediately at the same time. And you need that in order to, if you have like hundreds of variables, if you have thousands and maybe millions of observation, you're gonna need a computer that has a very fast video graphic card in order to do all this calculation. Because if you don't, you might be waiting like 6 months for your computer to do all the analysis. And of course, you don't have 6 months for a computer to do a machine learning model. You wanna get it done in like maybe at least 1 hour or maybe 2 hours. But you need the most appropriate machines to do machine learning are gonna be gaming machines. They're the most appropriate ones. Now, what else can you do with supervised machine learning? Well, I just discussed supervised machine learning, but you can use unsupervised machine learning as well. I'm sure you guys are familiar with Netflix and Amazon, how Netflix recommends the movies that you might like. And most of the time, they're actually correct. And Amazon, how Amazon recommends the products that you might like, the books that you might like, the music that you might like. And most of the time, they're correct. What they're doing, they're using unsupervised machine learning to make this recommendation. And we can use the same model, we can use unsupervised machine learning model to recommend to students the elective courses that they should take. A lot of times students don't know what kind of elective course to take. They don't know if they should take English, or maybe they should take French or Spanish, German. Sometimes they're very indecisive. So you can use unsupervised machine learning to make a recommendation to a student, and can make recommendation of a program as well that they might like in the future. So that's another way you can use unsupervised machine learning to make recommendations. Another way you can use supervised machine learning is to analyze faculty, student, and staff survey. It will identify those factors, those variables that are very important when it comes to student satisfaction, faculty satisfaction, staff satisfaction. It will tell you this factor had the greatest impact upon student satisfaction. This variable had the greatest impact upon faculty satisfaction. That way you can focus on those variable factors that had the greatest impact on improving student satisfaction, faculty satisfaction, staff satisfaction, and you can make a greater impact on your university and increase student satisfaction, increase faculty satisfaction, increase staff satisfaction. So you can use supervised machine learning to do this as well. And so those are things that you can do with machine learning. And I'm perfectly at 30 minutes. So now I have a lot of references. And when you put a lot of references in PowerPoint, it becomes it's not good. It actually decreases the font sizes and you cannot read them. So if you want all my references, just send me an email and I'll give you all my references. I'll be more than happy to do that for you. Here's my personal email address, and here's my Ashford University email address, and I have a YouTube channel as well. In my YouTube channels, I post all kinds of videos on machine learning, data analysis, economics, and all kinds of topics. So if you're interested, send me an email. If you want more information, if you have any questions, you can send me an email, or you can go to my YouTube channel and actually look at my videos that I have there related to machine learning, data analysis, and other topics relating to faculty development, faculty training.